Alright, now you have seen how to compute and draw the graph for correlation. It's time to go through regression analysis. And how are these different? We have seen that first, for correlation, we have two variables, and these two variables are the same quality. Let's say they are both continuous data. Whether dependent or independent variable are both continuous data. Okay, let's refresh and see the three types of data. The first one is continuous data. Example are just test scores, performance scores, or let's say temperature, let's say weight, and so on. And the second one is categorical data. Example is gender, because in gender you have two categories, male and female. Let's say colors, because in the color we have red, green, whatever. Let's say political parties, Democratic Republic, etc. The third one we have ordinal data. Ordinal data, when data are arranged. Example is marathon, the first one, the second one. Another example is grade. Let's say in a high school senior 6, one has been first, the second, and the last, like kind of arrangement. So now we know the types of data. And correlation, whether dependent or independent variable, are both continuous data, whether test, performance, like income. Yes. Remember in our last example, we have computed correlation between performance, student performance, and their parents' income. These both performance and income are continuous data. That's why they can compute a line like this. All right. For regression, regression now extends the types of data. Can be between continuous data and categorical data. Actually, regression analysis is a statistical method used to model the relationship between one or more independent variables and a dependent variable. It's commonly used to predict, understand the relationship between variables and testing hypotheses. In R, you can compute regression analysis using variable function depending on the type of regression you want to conduct. We have mainly three types of regression. The first one is a simple linear regression. The second is multiple linear regression. The third is logistic regression. But you have other types such as generalized linear models, robust regression, and nonlinear regression. All right, now we are going to compute the first one. Which is simple linear regression. Now, This one, the formula is simple regression. The formula is the function is LM or linear model. You start with dependent variable, tilde with an independent variable, and then you need to show the data. You provide the name of data. All right, that is the formula. So you can see it's just a simple linear regression. Is simple because when you have it is computed when you have only one independent variable and only one dependent variable. Okay. And in this case, it can be different from correlation analysis, because now on simple linear regression we have dependent variable which is continuous data and independent variable which is categorical data. Let's see an example in our data. We can load our data. The last file we opened last time is data new here. For correlation, we have used performance and income. Both these two are continuous and are dependent variable, only that one can be served as independent, another one can be served as independent. For a matter of fact, in clarifying, we use predictor in correlation and regression to differ from computation of means in ANOVA or t-test. So in this case, last time when you computed correlation, performance and income have been considered as predictors. Performance of student can predict the income of their parents, like this. All right, so for simple regression, we can give an example. LM, we can start with maybe performance, okay, tilde with gender, yes. Variables here, performance and the gender. You can see gender is categorical data, but performance is continuous data. So performance can serve as the as a dependent variable, and the gender can be considered as a predictor. All right, now the data, our data is the data new. We launch this and we got this one. If you open, you can open and see it's not very well clear. That's why you can come here and get a summary. Summary of simple linear regression. Okay. Here we have. Now we have linear mod. The formula we use. We have residuals. We have coefficients, intercept, and the gender. You can see gender has M. It means gender and the male student. All right. Now, what is the intercept? The estimation of intercept is getting 36% score. The software has taken as a female as a reference. That's why you can get the result of male. It means a female student got 36 scores. So a male student got more 7 scores. All right. It means for every unit on intercept or on a female, there is an increase of 7 score on that. So it means if a female student got 36, a male student should get 43%. This is how we interpret the results. And in the next video, we will see other types of regression and more interpretation.